This video is from liberprogramming.org, and I am Shivshankar Dayal, and I welcome you to this video. So in our last part we discussed exponentiation by squaring, and in this part I will show you how to compute that using a C program. So to cover large powers, I have taken x and y as unsigned, and x is long. So I take x and y as input, and then I pass that to a function called int power. Well, I must admit that this program turned out to be a little more difficult than what I had anticipated, and I learned a lot while writing this program. Now I have an array which has powers of 2 till 32, because I don't expect you will have anything this big as an exponent, because then it will be an overflow very easily. Alright, so that was passed to int power. Okay, so our first job is to split y into powers of 2. So I have malloced a pointer p which is of type int. You can choose bool also for this pointer p, and then I pass that p and y both to a function called split exponent, and I store result into max power. Okay, now this split exponent is but before okay, I pass it. Rather, before passing you could do this, right? If y is 0 or y is equal to 1, you don't really need to compute this, so you can put this before this. Okay, now we pass this y and pointer p here. So if y is say percentage y percentage 2 is equal to 1, I do this, not really needed, and then I start computing from 31 to 0, or rather you can compute from 32 to 0. So okay, I didn't go till that far. Okay, so now if I have chosen a signed int here temp, because y is unsigned and 2 powers is also unsigned. So if the both are unsigned, then this is never going to be greater than never going to be negative, and then we will have problems. So I chose a signed integer here, and then if this subtraction is greater than 0, so that will give me my max power, and then I subtract that power from y, and I make that index of p to 1, and then I repeatedly do this till our I is exhausted, and it is guaranteed from our last video that by the time we hit I is equal to 0, this will be exhausted, because any number can be represented as power of 2. So since we have already subtracted, we can make this 1 as well, or like let's be 0, one more step. So these little optimizations you can always do. So once you have got it, so what can happen is we are doing squaring, right? So our result I have taken as 1. So if p0 is 1, that is if it's an odd number, exponent is odd number, so I multiply the result with x, and then I simply go on multiplying it with the power, that is a square of square, if pi is not equal to 0, and I continue from 1 to max power, and then I simply print the result. So okay. So here we are. So I have already compiled this, and let's run this. So 2 space 1, so 0, then I say 2 space 2. So now this p0 is equal to 0 signifies, and p1 is equal to 1 signifies is 2 to the power of 1 is 2, and then if you see 2 space 3, then this signifies 2 to the power 1 plus 2 to the power 0 is it, and you add them, then that becomes 3, right? So that is your 8. 2 to the power 3 is 8. 2 to the power 4, so 16. Now you will say I might have made a mistake, so let's start computing. 2 to the power 4, so 81. So let's try 4 to the power 7, so 16, 384. That is as good as 2 to the power 14. Let's try 5 to the power 6, so this much. Or let's try to compute 2 to the power 32. So okay, so this rounded, right? Too big. So let's try something smaller, 2 to the power 16. Okay, this is also rounding for some reason. Okay, this should have been calculated, so there seems to be a mistake. Okay, the input is wrong, sorry. It's not 2 to the power like that, it should be space. Okay, so you got this number, right? 2 to the power 16, and this is 4 gigs, mind you. So you can compute even bigger because it is long, so maybe you can try something like 40. So it's a long, it will support it. And say you can try something different, 14 to the power 2, 196, 14 to the power 6. So you can do this, and you can experiment, but the most important thing is the code. So you can download this code. I'll give you a link. All right, this is a little bit complicated code, so you can download this code from, what link should I give you? Okay, I'll upload this code. It is not there as of now, so I'll put all the code here. So libreprogramming.org/source/int_power.c. So this directory does not exist yet. I'll upload this source code. Anything which is complicated I'll upload here, and then you can download from this link. I'll put this link on my website, and sources directory I'll create one, and then you can download from there. So I hope that once you read the code, it will be much clear to you how this has been computed. And to actually understand this, you will have to see the previous video, because if you miss the previous video, then you really don't understand this. Thanks for watching the video.